Let me move you guys over here. Maybe this over here. Yeah, people are still coming in, so we'll wait just a couple minutes more. I won't normally do this. Oh, let me start the recording. Where is that? Recording. Oh, where did that go? Oh, resume recording. There we go. Okay, now we're live. Hello, everybody. My name is Mark Friedman. I'm your instructor for this class. You can call me Mark. You can call me Mr. Friedman. You can call me Professor Friedman. I don't really care what you call me. I don't always answer to Professor Friedman. I'm not really a professor here, but I know that's what a lot of people talk to you about, like to use out of respect. That's great. A few of the TAs for the class, wave guys, or you might see video for them. We have you guys muted and no video for now. I just try to save bandwidth. I'm really worried that things will lock up, and just at my end, which would affect all of you. Let's see. Let's get started a little bit. Let me. I wanted to introduce the TAs. There's Josh, there's Shauna, there's Gibbs, there's Tanish. We lost his video. There's Steve. I'm going to try to have at least one TA watching your chat in the background, because I am not, while I'm paying attention to the lecture for all my classes. Steve volunteered to do that, and for classes in the future, Josh, who was just recently assigned as TA here, which was great, has also volunteered to do that. I think most of the material in this class is going to be new material for most of you. I doubt you've seen a lot of it before. As I go further and further into the slide decks, and trying to polish them up for future classes, I'm sure it's going to get more and more esoteric. We are a full class. We are not only a full class, at capacity, there are a number of people that are waiting for you, or listening in this week and hoping you'll drop. I've been fielding questions. We're not going to get any more capacity. The only way those people are going to get in is if some of you decide this class is going to be too much work, and it will be a lot of work. So keep that in mind. There are people waiting. They're anxious to get it. This is, we've offered this class for each term. Last year, I believe we offered it only for 2 terms. And yeah, we're booked for capacity. Obviously, we need more capacity in the department, I guess, but we're doing the best that we can. First day of a new term, you see friends normally, under normal circumstances. You see friends you hadn't seen for a little while. You get to talk about what you did and had fun over spring break. Not this year. So we're going to all try to make the best of it. All right, let me get to it. You did see the letter I sent you over the weekend to try to give you an idea. So also that'll help me. I won't have to spend lots and lots of time on that, some of that stuff. But we are definitely still trying to figure some of this stuff out. This is my first time running a Zoom meeting with this number of people, for instance, and with some of you not having Q&A. We'll see how some of that works. A little bit of news. Your first assignment is posted. See the course website for everything. It is due next Monday. I think Gradescope is wrong at the moment. I'm sure that'll be fixed soon, but it's due next Monday. It's a very easy assignment. It's just to get you started. We'll be using Gradescope, of course, to submit it for grading and things of that sort. All right, let's talk a little bit about the subject of the class, which is database management systems. We're going to learn really what a database management system is and why it's important. just as note, Dan Succi, who's a professor here in data management, he likes to start off with a couple of the folks, people who have contributed to computer science sufficiently to earned Turing Awards. They include Ted Codd, who's the one who came up with the relational model, and they include Jim Gray, who is responsible for basically the unit that we're going to do on transaction processing. I also like to mention in that, and make it a triumvirate, Peter Chen, who is not a computer scientist, so he's probably not considered maybe as important to computer scientists, but in the world of data management, his contributions are certainly every bit as important as Codd and Gray, and he's responsible for entity relationship data models. I've been doing this, working in this area for 40 plus years, and so, I've seen the introduction of Codd's work, the impact of Gray, the impact of Chen, things of that on the industry, and it's been profound. We will try to look at real world examples. No, we will try. We will more than try. We will more than attempt to do that. I will try to for you with real world examples. In fact, when we look at a DBMS, we're going to look at a real world example of a DBMS, one that generates $5 to $10 billion in annual revenue for the company that makes it. So these are, and the people that use it rely on it for a myriad of things. All right, let's just do some administration stuff. Let me go through quickly what we're going to be doing before I get into it. So the course topics are really the relational DBMS. We'll learn what that is. We're going to be looking at queries, database design, query optimization. We're also going to look a little bit at transactions. We are probably not going to say too much about parallelism. It's such a broad subject that I don't think we can do justice to it really, but we'll mention it at various times toward the end of the class. And then we're going to do a little bit of fun, try to have a little fun the last couple weeks of the class, assuming we can make as good a progress this mode of delivery as we can in a normal mode. We'll be looking at what I call beyond SQL, beyond relational database technology. The industry the database area has exploded really in about the past 10 years. And with lots and lots of people doing very, very interesting things, and we'll try to get a chance to look at a couple of them at least. I really want to emphasize that we're doing hands-on learning. We're going to be working with professional tools. We're going to start with this product called SQLite. That's the subject of your first homework, getting that installed, and writing a few, loading it up with a little bit of data and writing a few queries against it. I guess in the case of SQLite, I personally consider it somewhat semi-professional, but I know it is accepted and used around. I don't like it for a number of reasons, which I'm sure you'll hear much more about as we go forward. Then we're going to switch after about 2 weeks to use Microsoft SQL Server. There are options which I wrote about in the letter to you. We can all use SQL Server using cloud services, and we've got going to set you up with Microsoft Azure accounts. We have an arrangement where Microsoft very graciously helps fund them. I guess they get something out of it as well. You also have options to locally install which SQL Server on your machines for better performance. And I think I discussed that a little bit. And then we will do a unit that involves us using CosmoDB on Microsoft Azure, one of the newer databases. We'll do some stuff with Hadoop and Spark and things like that. I didn't have room for everything that we're going to be doing. So it's going to be lots and lots of hands-on. The homeworks where you're using these tools, where you're learning how to code in SQL, you're learning how to set up databases and things like that, they're probably the most useful aspects of the class. The skills that we're going to be talking about here are likely to be extremely useful throughout your career working with digital data. A number of you have talked to me, or actually I've been all week fending off people who would like to move into some kind of area of data science associated with whatever their major is, and working with digital data, big data, and this is kind of the gateway drug to that that sort of work. These are some of the things that you'll be able to do after you get through the class. Mostly we will be focusing on how to execute a query, or how a query is executed and processed end to end. I'm big on understanding the principles of logical and physical and database design. I don't know you're going to learn enough to make that good a design choice when selecting tools, but you'll be familiar with some tools that are very much popular out there in the marketplace. Just a note here is that nearly every one of the apps that you interact with on a regular basis runs on data managed by a DBMS. This stuff is everywhere. And the effect of this class, I think, is that this is going to be your first peek behind the curtain to see how these data-driven applications work. Hopefully your reaction is going to be something like, oh, wow, so that's how it works. That's what we're going to be discussing over the course of these next few weeks. Oh, so your data is in the cloud. Guess what's behind the cloud? Another database. So the cloud doesn't maybe changes the physical location of where the database is, but I assure you the database is still there. Okay, so that's me. You see the other folks who are online, but a full list. Josh, I'm sorry, you didn't make that list. I will add you. Josh was just given to us as an extra TA because I requested some additional resources, and they were nice enough to give him, and he didn't make the list. He is out on the website, and there's a picture of Josh. And Josh, you can wave now, and he's sitting amidst the Aurora Borealis, apparently. In case you're wondering, that's me in the foreground. I'm not sure the name of the fellow in the background. Okay. Let's see. Let's try a Q&A. Let's try a Q&A. Does somebody have a question they would like to ask? How do we go about doing that? You like raise your hand kind of thing on chat? Who's following chat? Which of you guys are?
Nobody said any. Okay, somebody just asked if we have exams in this class.
Oh, okay. Good, good. And who said that?
Peter Nye asked that.
Peter Nye, and he's in. What is you're watching? You're managing the chat. I'm not seeing that.
Yeah, it's in the chat.
Chat. Oh, I see some chat here. There we go. Are we going to have exams? There you go. I need to check this from time to time. Are all assignments, hang on, guys, slow down. Okay, I'm getting them. Okay, let's talk about some of them. I got hi. We'll try not to do that. Bradley. Okay. I vote by the green screen. Thank you. No, there's really not room for it. Are we going to have exams? I'll get to them. When are the midterm and the final? I'll get to that. Are all assignments due on Monday? Decidedly not. Are all homeworks turned in through GradeScope? That's the current plan. What is the format of the exam? A very difficult, painful thing. And how approximately how long homeworks will take, I think that depends on the homework. And actually, I am not as conversant as the TAs are on the homeworks. I've actually never taken the class. I just teach it. They know about the homeworks, and you have a section with them on Thursdays. The one thing that this has come up is, what if you can't make your section, your particular section that you're registered for? And I would suggest that you just go to one of the other sections that you can make. We will be trying to schedule an additional section, which Josh, wave there, Josh, in the Aurora Borealis, where you're in Anchorage at the moment. That's nice. Me, I thought it was Bellevue. We're going to have an extra session. I don't know if that's out on the website yet, is it? We decided to have it, but we'll have one after hours even, so that there won't be scheduling conflicts. We have a number of people who are not able to take the class live unless they want to get up at some, very, very difficult hour. And they'll just be watching it as a recording. All the lectures are being recorded. And we wanted to have some sections and office hours, virtual office hours, to accommodate them. Say hand. Okay, very good, Tanish. What's the curve and median for the course? I haven't really looked into it yet, and let's let that happen. Okay, we're good with chat. I'm going to move on if we don't mind. Okay, I see a little bit how that process works. That's good. I enjoy the interaction. That's one of the most valuable parts of, I like to think you're out there doing something useful, that I'm doing something useful. Okay, now I have a couple of questions for you, and that is, let's try this built-in polling feature. So I'm going to launch polling, and you get to tell me a little bit about yourself. Please don't be shy. I'm actually quite interested in some of this demographic information. It seems to me, my view of the material is that this is very basic stuff, and I can approach it from a number of different ways. So knowing a little bit about your background helps me sometimes in figuring out which are the ways to try to do it. So go ahead. I'm getting lots of answers here. That's good. All right, you see I have a lot of questions for you. Now, do you see the results the way I see them as well? Or am I the only one who sees them?
Looks like just you.
Ah, okay. Well, that's interesting. Okay, well, I'll figure out, attendees are now viewing the questions. And I'll give you another 2 minutes. We'll give you a total of 3 minutes.
You could probably share the results if you share that part of your screen.
That is true. Good idea. All right. I don't think we're getting a lot of answers at this point, so let's stop the polling. I'll wait till 2 minutes are up. There you go. Very good. Thank you, Shauna. All right. So you guys can all see that. All right. How many classes have you taken? Less than 3. So this is less than 3. That's interesting. Okay, we got a few ringers, as you can see. Are you an undergraduate student? Most of you are an undergraduate, but there are some graduate students slumming. I'm not sure what that is, but you might want to communicate to me. Are you planning to minor in CS? Yes, a few. Most of you know. Okay, I was curious about that. A bunch of you, though, are considering majoring in CS, and I did try to address that eventuality in my note to you. We're going to try to track CSE414, which is taking place at the same time, well, not the same exact time, but days and weeks term. We're going to try to track along. We'll diverge in spots, but we're going to make an effort. It's a little complicated by the amount of extra work that both Alyssa and I have to make this thing go. What platforms do you run? I'm not happy with this result because I don't really know. Most of you only have one platform, I'm going to guess, and it's about split half and half between Windows and Mac. Some of you, I imagine, with Mac also run Windows. There will be an advantage to you to run under Windows because once we get the Microsoft SQL Server, of course, it is a Windows. It's not. It can install on other platforms, but the tools, the better class of tools, run on Windows. That's about the only thing you'll be lacking. There's some pretty good tools that'll run on Linux, and I did try to identify them for you. Just wondering where everybody is. So only a few people, and you see we've got 12 people outside the US. And we do have one person. Oh, it says share the results. So I could do that. I don't know what that does. What happens there when I do that? It pops up. Is that correct? And now you can all see it?
Got nothing here.
Nothing here. Well, I don't know what happened there. Here you go. Let's go with your idea, Shauna. Okay, well, we're done with the poll. I'll publish that if you'd like. If I can, if it doesn't go away. All right, let's go back to some slides. I see how that works, and we'll try to use that a little bit. It's nice. We have sections. That's where a lot of the hands-on learning. Also, if you're stuck, that's where you'll get unstuck by some very knowledgeable and friendly teaching assistants. See the website, you've scheduled them. They're going to be run as breakout meetings. I don't know, we're going to experiment with that. We'll have our, some people may want to try it various ways, and we'll see kind of what works best. But anyway, we'll start to work the kinks out on that beginning on Thursday. You have 8 homework assignments all told. No, they all won't. The first assignment is installed. They won't all be on the website by tomorrow. We're in the process of changing a few, tweaking them here and there, and we've also got to do the work for Gradescope, which is new. So that is not true. That shouldn't be on the slide. I must have inherited that from somebody. I do think if you think about the amount of time that's involved, I just wanted to emphasize again, we got lectures, we got sections, we have readings, we have homeworks, we have tests. We do have tests. We will have a midterm. The exact scheduling of that is to be determined, but it'll be sometime in the middle of the term. And we do have a final schedule for June 11th. These will be time tests administered via Gradescope, probably. They'll be open book, they'll be open internet, they'll be, you're going to be wherever you're going to be, they'll be open everything. You are on, you'll be asked to affirm that this is your own work. I hope that it is. And what the final will be under the same circumstances. The textbook looks like this. It's a brick. I gave you some information on that in the note as well. I realize the textbook is a brick. I realize it's expensive. I consider the textbook to be quite good. It's very authoritative. It's very complete. They're not kidding when they call it the complete book. Frequently when I'm struggling trying to understand what somebody else's slide meant that I've inherited here, I go to the book and find much more authoritative and informative kind of explanation of the things that other people are struggling with. We are not going to read the whole book. Good Lord, no. So I'm giving you very targeted readings that are timed to the lectures. And I gave you your first reading assignment, and that reading assignment should carry you for about the first 2 weeks of the class. So I do urge you to get the book, to read the book. It's not like you're going to sit back and enjoy the book. I realize that. But read as far as you can get, and follow along with my lectures. Either read it in advance of when I'm lecturing on the topic, or to encourage you or to reinforce some of the things that I'm talking about afterwards. I do want you to read the book, and I will hold you accountable for aspects of the book, parts of the book that I don't have time to dwell on in the class, as I also said. And I guess I'm trying to emphasize that. If you're interested in buying more books, this is a pretty good book. The one issue with the Molina book is it's getting a little bit old. The last edition was published in 2009. Now, relational database management technology, the heart of the class, hasn't changed that much since 2009, possibly in minor ways or in very interesting high-end enterprise ways. But there's lots and lots of new developments in database world, as I mentioned, and unfortunately, because of the timing of the book, and that's wrong on the slide. It's actually 2009. A lot of that material, of course, doesn't make it into Molina. So one of the things that's nice is if you want another book, also if you're confused about Molina, but you'd like to triangulate, I mean, I certainly used to do that when I was a student. So this is a pretty good book. Okay. So everything we're trying to put everything in one, consolidate everything in one place, which is our website, and hopefully you've been there. When it looks to be grading, we're looking at 30% of your grade determined by your homeworks, another 30 by your midterm, another 30 by your final, and I've got 10% that I'm not sure how. I haven't determined, and all of this is subject to change depending on how the class goes. I know a number of instructors, teachers here that basically canceled their finals because they were impractical. But I don't think we're going to be. You have a bunch of late days, just use them judiciously. It is dangerous to fall behind. If you do need to fall behind for some reason, please let your TA know, or please let me know, or both of us. It's dangerous. Initially, we're going to do the labs individually. But then I think we're going to take an opportunity to try to get you, if you want, to work in a team, and we'll see how that works. You guys are going to be teams remotely for the most part too, I imagine. But if you can do that however you want. We'll see how that works. We're not going to start that the first couple of labs. You just do individually as we're messing around with SQLite. We're using this ED discussion board. I haven't seen anybody jump to the board, but there shouldn't be that much to discuss yet for Q&A. None of us involved in the teaching the class have used ED before. It comes highly recommended. We'll see how it goes. If it doesn't go very well, we'll switch to something else. We're using Gradescope. As I said, we got someone who's had some experience with it, and she's going to be training the rest of us. Canvas, we're going to use only for announcements. And the mailing list, the same thing. I did send that mail out, and if we have some way of, something that we have to communicate with, we'll use those vehicles. Okay, let me look and see how my chat is doing. And has anybody got anything else? Somebody wants to know what the median of the GPA of this class is, and I don't know. I do know that I'm given a fair amount of discretion this term because of all the extraordinary things that we're doing. As I said in my note to you, I'm not looking to trick anybody. So do a good job, learn the material, and you'll do just fine in the class. All right, let's get started on some more interesting, unless there are questions. On the website, on the site, where the slides will be posted. There is a set up there now that's fairly current, just doesn't have the homework announcement on it, and I'll post this afterwards. I'll also post the recordings there. So if you want to go back and listen to them. I don't know why anybody would want to listen to me again, but okay, in case you do.
Mark,
yes.
A couple students were asking which parts of the class have mandatory attendance. Can you clarify that?
Well, can I clarify? Mandatory attendance. I think all parts of the class are important, so I'm not going to make anything mandatory. I think you should get to all the sections, and if you can't get to the section in which you're registered to, you should get to somebody else's section. I don't think we're going to care what section you're in. And as far as the lectures, if you can't get to a lecture, they will be recorded and you can do them. And if you can manage to do the class on your own and get a 4.0 without attending class or a section, more power to you. That's up to you. I'm not taking attendance if it comes to that. Does that answer the question? Okay, so subject of the class is really about, well, the prereq for the class is CS414, which I haven't taken here, but what I understand is data structures and algorithms and things of that sort. And I can imagine that in the exercises, the programming stuff that you did in that class, that you essentially recreated the data. Every time you executed your program, you recreated the data that you used to traverse a list or do some kind of binary tree search. Well, that's not actually what happens in the real world. What happens in the real world is this data is persistent. It's persisted on storage media, mostly disk storage media, but more and more today what we call non-volatile memory, or SSDs, where it's kept secure, it's backed up, it's duplicated, it's replicated, it's protected against unauthorized access. So underlying computer technology is a whole set of digital data storage technology. When we talk about that kind of digital storage, we're talking about files, just like the files that are your PowerPoint stuff. Where is that kept? It's kept on your hard drive, things of that sort. The files themselves consist of a series of records. Many files are just sequential to start. And they may not have much in the way of delineated fields. They might be just sort of text fields, but you're familiar probably with comma delimited kinds of fields, or comma separated, or those kinds of things where there are a number of fields embedded in each record. So the way this kind of evolved is we started with those kinds of sequential files. And in fact, the first 15, 20 years of maybe 10 years of computerization involved media that in effect was only sequential. I actually worked on computers with punch cards in the early days of my career. And I never did it myself, but I worked with some that had paper tape that you would feed in, which is interesting. Very quickly, people had one of the first media was a magnetic tape, which are these things that rotate, and often in a movie they want to depict the computer system and they need something that moves. And of course, computers are entirely electronics and nothing moves, but the tape drives move around, so you often see them. But they were used for storing, offloading data to disk that could be then reread into your program the next time you ran it. The big innovation was the development of magnetic disks. So your computers typically have hard drives. So this would be HDDs, hard disk drives. And hard drives have a mechanism we'll get into a little bit more, but that allows for you not just to use to access data sequentially on the hard drive, but to access data somewhat at random around the disk. And this led to the use of indexing in files and key direct access files and things of that sort, all of which was a prerequisite, the precursor of current databases. These days, that's all changing with magnetic disks. We've been waiting for this development for SSDs to become inexpensive enough to, because they're much, much faster. And to get them into computer systems these days, they're mostly configured to emulate the hard drive semantics, so you don't have to write new drivers and things like that. But this has been a revolution, and makes some other earlier assumptions that were hard drive based, in my view, obsolete. So if you think about the way I like to think about it is this subject is about what happened to all that data in my lists and my trees and my arrays and all of that when I wanted to persist it. And you should think about database management systems, I think, as data structures on disk. And we will use at some points in the class some of that background that you have in data structures to talk about the kinds of data structures that we use for data resident on disk. It's a major topic of the class, as a matter of fact. There's a distinction we make between structured and unstructured data. Think about, say, you have product review data on Yelp. You've got a certain amount of, some of the data is quite structured. Did you give it the restaurant 4 stars? Did you give it 3 stars? That could be represented in the database as an integer. It's a strongly typed field, so that's structured. Then you have the review. The review is some type stuff, and they might have some limits on the size of it. It's unstructured text. It doesn't make sense. Maybe it has paragraphs and things like that associated with it, but in terms of digital data, it's unstructured. Now, store them together. You know, I got my review and I've got my star rating. That suddenly becomes a structured data, a data unit. Okay, now we talk about what happens when you start to get lots of this data, but the data is related. Like, we have products, we have customers, we have product reviews, we have all of that stuff. Now you're starting to talk about the realm of databases. And that's where databases evolve from the need to manage multiple related structure data files. Okay. And you might not get the full flavor of this until we start in the class to deal with multiple related data files in the class. It'll look pretty simple at the beginning, but it's going to get complicated pretty quickly. Okay. Let me see. Let me look at the questions here. Does combining structured and unstructured data always result? In my view, yes, but we're just making it up. That's just my view. Did I miss anything else? Okay. Okay, so let's look at what do we mean by a database? So what we mean by a database is a collection of related data files, which now the database management systems are specialized data management software that controls things like the access to the data, the security of it, the integrity of the data. In fact, they're quite involved. And we'll learn about some of that. Let's look at some examples of databases. Look at the Amazon products database, look at the Facebook database of friends and their connections, airline reservation information. And in particular in this class, by the way, we're going to look at we'll drill in on a sort of a sizable, but yes, manageable database that's called webscorer.com. So I don't want to bog us down today in that, but we'll get a pretty good sample of what a actual production database looks like from looking at the WebScorer stuff. What do we mean by a DBMS? A large, complicated set of software programs, usually written by somebody else. Some of you may go into the business of writing DBMS software, though I don't know. And that allow us to manage this database of information that's persisted over extended periods of time. Examples of DBMSs include the following: Oracle, IBM, DB2, Microsoft SQL Server, Vertica, Teradata. Most of them are considered relational databases. I don't know what you would consider Teradata offhand. It's a big data app. But there's open source examples of it. There's open source libraries like SQLite. We will be focusing on relational databases most of this quarter. Let's look at an example. What data do we need? What capabilities on the data do we want? So suppose we're an online bookseller. What kind of data do we need? Does the business need, let's say, data about books, customers, orders, order histories, things about that? You want your probably interaction with the website, so you want data about sessions, clicks, et cetera, et cetera. The data must be persistent. Must outlive the application actually, running in any instance, and note that the data is apt to get quite large. What kinds of capabilities does the bookseller need? Well, the bookseller needs to be able to insert and remove books, find books by author or title or things of that, analyze past order history, look at recommendations. This is data that must be accessed efficiently, potentially by many users, and it's data that must be kept safe from failures. These computer systems do fail for many, many different kinds of reasons, or malicious users. So these are some of the things that a database, think about what a database, a DBMS does. It's about real world entities. It's the storage of large data sets persistently. It has you have the need to query and update that data efficiently. You need a database. It has the ability to change the structure, add or subtract attributes dynamically. It needs to be able to handle concurrent updating. It needs to be able to recover across crashes. It needs to provide security and data integrity. This is what's led us to the current environment where we have, talking about big data, huge amounts of data that's going online and managed by databases. Cloud computing is along the same lines. Okay. Now, step back a little bit when we talk about how do we describe information, in terms of its semantics, I guess. These are usually considered semantic networks of various kinds. We're going to talk about them as metadata. When we're discussing how we're discussing the characteristics of data, we're up a logical level, therefore the term metadata. We're going to be dealing with conceptual data models in the class. What is that? We're going to see them in a couple weeks. A data model is a mathematical formalism that's used to describe data. What kind of mathematics? Well, it turns out to be something like set theory. It is how we talk about the data conceptually without having to think about its physical implementation details. We'll get some of that in a little bit more detail, but basically the approach is known, the most popular approach is known as the entity relation approach to data modeling. We have things like entity sets, which are collections. Think of them in terms of your data structures experience as collections of entities like customers, products, etc. You see all of them there, and each entity has a set of attributes or properties. Relationships. What kind of relationships are we going to model in our databases? I don't know. Is a, has a, contains, owns, parent, child, all kinds of relationships, and we'll see how that's going to be manifest. Here's an example of, again, from our publisher. We've got customers, the relationship of an order, that is, a customer orders titles, a publisher supplies the titles, the customer order contains one or more titles, the warehouse ships the customer order, hopefully. We can also talk about those relations in terms of, we'll see multiplicity. In other words, are those relations one-to-one? Are they potentially zero to many, or those kinds of things? And we'll talk about various constraints on those. In other words, nobody can order a title if it doesn't exist in the database. And we can't ship a title that's not in the warehouse. So these would be constraints. They can be built in, and they typically are built in to the database itself. We have an opportunity to discuss many different types of DBMSs, but in this class, we're going to be focusing on relational databases. Just to give you an idea of that, let me skip ahead of that. For instance, suppose we're looking at representing Facebook friends and connections. So here's Joe and Ann and Bob, and they're explicitly represented in a graph model, and there are graph databases. In the relational model, you would see a representation that's more like this. It's rows and columns, and in effect, it looks a little bit conceptually like a data stuck in a spreadsheet. It's a little bit more complicated than that, as we'll see. So there's lots of models out there. We're going to be talking mostly about relational. This slide explains when relational concepts were first introduced, 1970. Most of you, I doubt any of you were born then. I was around, but I wasn't in the computer industry. I was in college. Is relational database technology a good choice for the class? Well, I went out to this website. There's a bunch of rankings out there that are updated. This was the latest one in February. And I don't know, the top 6, 7, and the 7 or 8 of the top 10 are all relational databases. It turns out, yes, this is a very valuable, most of the data you're going to interact with in the world is probably managed by a relational model. There's a picture of Cod. There's this picture of his Turing Award. He's responsible for the relational model, and what do we mean by that? Well, a relation is, this is an example of a relation. What we talk about first is the schema that describes the data. And so we have a schema here for a payroll relation, which is a table or a collection of records. And we have some fields associated with the payroll. Here's how there's an instantiation of some payroll data. This is not real data, but I think the TAs would like this to be real data. The professors probably not so much. So there's some real data. Now, when the terminology we're going to use, and unfortunately for you guys, I'm going to use this terminology interchangeably because, in fact, we do. If you want to talk about this in terms of relational database technology, we often call it a table. If we talk about it mathematically, it's a relation. If we're talking about the rows of data, in relational terminology, those are called tuples. And sometimes I'll also talk about them as records just because I'm very old-fashioned. And the columns of information are also known, again, in the relational model as attributes, but we're accustomed to talking about them as fields as well. So let's quickly talk about what the characteristics of the relational model are. It's originally defined with set semantics. And then people, because that's where they got the idea of relations are a fundamental piece of set theory. And then somebody noticed that unfortunately, actually duplicates are not allowed in sets. So they're not really set semantics. They're actually semantics of bags. But we're so accustomed to you saying we're using set theory that we'll seldom remember that we're actually using bags. So from most of the time, I would just say set semantics, and you're supposed to substitute in your head, he means bags every time he says sets. Thank you. We have attributes, and this is the difference between data involved in your database, because it is preserved and on disk, it's typed and it's static. And there are only specific types of data. There's quite a few, but data types that are supported. And we call the tables themselves flat, where they consist of uniform rows and columns. I guess that's what flat is supposed to mean there. It's two-dimensional. The order of the data in the tables doesn't matter. It will, from a theoretical standpoint. Actually, the data is often ordered, and the order will matter, but that becomes the question of physical database design. Well, how should I order it? And we're not going to get to that yet. But initially, let's consider that these are equivalent relations. From a set theory standpoint, they are equivalent. They are the same relation. Order does not matter. You can't do this that would violate set semantics. Here's a duplicate row. It doesn't violate bag semantics, however, so you can get away with that in many databases. This is something you can't get away with. Here's a salary field. It's typed as an integer. That's the way that field is stored on the disk. There's room on the disk in that field for 32 bits or 64 bits or whatever the size of the integer is chosen. It's a type. You can't stuff banana into it. Banana won't fit in 64 bytes and won't be interpreted as a character string by the computer. It's strongly typed. Also, the relational model, and this will become very evident as we go forward in the class. We're just going to assume this. There are no subtables. Everything is flat. There are no repeating fields embedded inside a relation. Okay, well, it'll come up all through the class probably. How's the data actually stored? We don't know. At this point, we don't know, and actually we don't care. This is one of the principles that has really helped the relational database systems, is that there is this principle of physical data independence. As peeking behind the curtain to see how this stuff works, some of this stuff will actually matter, as we'll see. Okay, I've got a couple of minutes and not much, a few more slides to go through. I'm going to go through them quickly. I have the data, I have the schema. How do I access it? You can read that on your own. We use a particular language called SQL. It's based on first order logic. Very few of you have had that, but allows for a logical interaction with the data. This is the general syntax of a SQL statement. You select the data, you tell me where it's from, you add conditions to the selection, you can aggregate it, you can add conditions to the aggregation, and you can order the final result set. So that's kind of how that works. And in our hello world scenario here, where we had this payroll schema set up in relational database, we would have this SQL statement would execute. It tells me what kind of data I want. I want these two fields, the name field and the user ID field. It tells me where to get the data from, and it filters the data. When this statement is executed against something like SQLite, it will generate this relation. So the output of a query is another relation. And I think we've come to the end. Your homework's available. Let me look through chat a little bit and see if you're going to hang around. See what kind of questions you had. I know I went through a lot of it in a hurry. That all looks good, what you guys are saying. We're going to cover a lot of this in detail, but don't be too confused about it. And again, let me go back to this slide. This is the thing that probably generates the most changes, questions, which is, and unfortunately, these are equivalent. Table When I mean a table, I mean mathematically a relation. When I'm talking about columns, there's different ways of using that, but columns of data, they're strongly typed, as I said, they're attributes or they're fields. Rows and tuples are the same thing. I'm mostly going to use the term rows, but tuple is the proper term from a mathematical perspective. Is there a particular order you have to follow in SQL? Yeah, unfortunately there is. No, the individual statements don't have to be in any particular order, but it's customary to write them in this order. They have to have a semicolon at the end, and there's a parser, and the parser will syntax check it, and any way that the parser is happy with, and the parser themselves will vary with the implementation. And there are some dialects of SQL, unfortunately. There are standards as well, but there are some dialects where perfectly good SQL that's good for SQLite will not run in SQL Server or Oracle or things of that sort. So you get the hang of it after a while, though. It's relatively standard. Any other questions? Okay. I'm going to switch over to the other. Thanks, everybody. Your homework is there. Have at it. We'll see you again on Wednesday. And I'm going to switch over to the other section, if you don't mind. And there you can come and ask me a question one-to-one. I'll give you one last opportunity to ask a question here if you want.